So now we are going to see that the methods of producing the induced EMF. So d by dt of. So now you can see that current flow through the via the electromotive force or EMF is energy provided by a cell battery per coulomb of charge passing. Measure that volt. It's equal to the potential difference across the terminal of the cell that no current is flowing. So source of the electromotive force which is connected to the battery. So current is flowing like this. So induced EMF is given by the expression E equal to minus d by dt of NBA cos theta, where B is the magnetic induction, A is the area, cos theta is the angle. So you can change any one thing, the magnetic induction or area enclosed by the coil or orientation of the coil. You can produce the induced EMF E. That means you got d by dt. Remaining things are constant. You can change only magnetic flux B. Or you can change the dA by dt, remaining things N, B, cos theta are constant. Or NBA constant, you can change d cos theta by dt. So you can change any one, you can produce the magnetic induction. Now you are going to produce the induced EMF by changing the magnetic induction. That is dB by dt. See here, E is equal to minus NA cos theta. Minus NA cos theta. Here number of turns, area, cos theta are constant. Now you are going to change the magnetic induction dB by dt. So how to increase the magnetic induction? So when you increase the flow of current, magnetic induction also increases. So when you increase the magnetic induction, you can produce the induced EMF. E is equal to minus NA cos theta by varying the magnetic induction dB by dt. Second thing is that EMF is induced by changing the area enclosed by the coil. Now you can consider that conductor PQRS is a closed conductor, a sliding conductor on that. So using that you can change the area. So M1 L1 to M2 L2. You are changing the distance, moving the distance dx. Perpendicular to that conductor, B magnetic induction is acting perpendicular to the conductor. See that red line indicates that perpendicular. So what will happen that when the change in the area, here magnetic flux is there, conductor is moving in a distance of dx. So initial closed surface area is RQ L1 M1, new one is RQ L2 M2. RQ L2 M2. No, so we are increasing that length distance. We are changing that area. We are increasing that area by moving the sliding conductor. Initial area is very small. Now we are increasing that area. So changing area. So here we are going to change that area. We are not going to change the magnetic flux or number of turns or the angle cos theta. Only we are changing the area. So dA by dt remaining N d cos theta is constant. So now you can do the calculation. See that area, initial area and final area, we are changing that area L2, L1, M1, M2. That is changing area dA. So L into dx. Dx is the displacement, L is the length. That is rectangular area. Multiply that. So according to that, d pi equal to B into dA or B L into dx. So B அப்படியே இருக்கு, dx பதிலா L into dx. According to the Faraday's second law is equal to minus d pi by dt. So we are substituting that value in this equation. Bl is a constant. So Bl is a constant. Dx by dt is the rate of change of velocity. So instead of dx by dt, we can write that velocity v. So induced EMF v is equal to minus blv. V is the velocity of sliding conductor is moved. எவ்வளவு வேக velocity of the conductor நகர்த்துவீங்களோ அதுதான் அதனுடைய velocity. Okay. So V is equal to minus BLV. So this is the induced EMF by changing that area. First நாம் பார்த்தது by changing magnetic induction. Here we are changing that area. An EMF is induced. E is equal to minus BLV. It's a very important formula. So next we are going to see that by varying that angle. So by varying that angle, how we are going to change the induced EMF by changing the orientation of the coil. So coil, you know that PQRS. You are taking that PQRS as a coil. That coil is placed between the magnetic field. Okay. By changing that angle, orientation means we are going to change that angle. Angle, how it will change? By rotating, that angle is increases. So that angle theta is changes. By changing that angle, so EMF is produced. So now you can see that EMF induced by changing the orientation of the coil. So PQRS is the rectangular coil, net number of turns and area is A. It is placed between the uniform magnetic field B. So it is moving like this. Angular velocity omega, clockwise direction. You know that rotational motion, it has the angular velocity omega. Axis perpendicular to the direction of the magnetic field, vertical position, coil vertical position, it's perpendicular to the magnetic field, the induced EMF becomes 0. Already you know that. So time period T, that angle omega equal to theta by T. So omega equal to theta by T or theta equal to omega T. If phi is the flux linked with the coil at this instant, any instant, it is rotating between the magnetic field. So here pi equal to NBA cos theta. Here number of turns, n is constant, magnetic induction, that is magnetic field also constant, area of the coil, that is also constant, but here theta only it is changes. So according to the Faraday's second law, E is equal to minus d pi by dt. So substituting that value in this equation, what will happen? We have to differentiate that pi. So all the constant value, NBA is a constant, d by dt of cos omega t. So differentiate that, you will get omega sin omega t. Omega sin omega t. In this equation, NBA omega we can take as E0. So this value here we are going to take as E0. So E0 is equal to NBA omega. So instead of this, we can write E0. So E equal to E0 sin omega t. So E equal to E0 sin omega t. So induced EMF E wave is sinusoidal. Sinusoidal waves means it's a sine wave, you know that. With time t and the frequency equal to angular velocity by total displacement. Velocity by displacement. Velocity is angular displacement omega divided by the displacement 2 pi. Now you can see that when omega t equal to 0, the plane of the coil is perpendicular to the field. So perpendicular to the field means that induced EMF is 0. அப்போ காயில் வந்து எப்பவுமே அப்படி பர்பண்டிகுலரா நேரா இருந்துச்சு அப்படின்னா induced EMF is 0. When it is parallel to the magnetic field, it has the maximum value. So see that how the EMF is induced. So it is perpendicular to B, the induced EMF is 0. So that point is the the dot is indicating that induced EMF. So when it is parallel to B, it has the maximum, that is pi by 2. That is yellow color dot is indicating that. Then again it is rotating 90 degree, it will come to like this 180 degree. 180 means again it is right angle to B, again it is 0. Now 180 again pi by 2 rotation, it will 270. So parallel to B, but in a opposite direction. So that will put 3 pi by 2. Again it is rotating 90 degree. What will happen? Again it will come to in a perpendicular to B. So again induced EMF becomes 0. So like that it will produce the induced EMF. That the ends of the coil are connected to the external circuit through the resistance. The current flow through the circuit like this, which are sinusoidal in nature. Sinusoidal wave. This is the nature of this wave nature is called sinusoidal. So this is a sinusoidal wave. So like that EMF is induced in the coil. So this is called generator. So it generates the current like this. So I equal to I0 sin omega t, E equal to E0 sin omega t. For potential of this wave, E equal to E0 sin omega t. Our flow of current means I is equal to I0 sin omega t, where the sin omega t means that is a sine angle. So this is the third method of by changing the orientation of the coil, we can produce the induce the EMF. Okay. Next thing is that alternator அப்படிங்கிறது is a generator. The generator எப்படி ஒர்க் ஆகுது அப்படிங்கறத நம்ம பார்க்க போறோம். The generatorல என்ன, what are all the important components are there? Then அந்த componentsல எப்படி வந்து நம்ம இதை யூஸ் பண்றோம் அப்படின்றத பார்க்க போறோம். So alternator அப்படிங்கிறது is used to produce the electricity. That's called alternator. கார்ல இருக்கும், பைக்ல இருக்கும், எல்லாத்துலயுமே இது இருக்கும். alternator அப்படின்னு சொல்றோம், ஜெனரேட்டர்ல இருக்கும். Okay. So it has a two important parts. One is the stator and one is the rotator. Stator means that coil, that is stator and rotator. So both are coils, but one coil is used as a magnetic field, another one coil is used as a coil which is used to produce the current. Okay. So see that how the Alternator's parts are there. See that. That alternator is a electrical generator that converts mechanical energy to electrical energy in form of alternating current. Electricity produced in alternators by electromagnetic induction. There are two types of production of electricity. So one is type 1 is that rotating magnetic field with a stationary armature. Coil வந்து stationary இருக்கும், but magnetic field வந்து சுத்தம். The type 2 is a rotating armature with a stationary magnetic field. Magnetic field stationary இருக்கும், coil வந்து rotate ஆகும். So there are two types. One is that the stationary armature magnet will rotate. That another one magnet will stationary, that coil will rotate. There are the two types of armature. Now you can see that these are the different parts of the alternator, and this is called rotor. So it's called rotor, and this is called stator. Stator means it's a static. இது வந்து ரொட்டேட் ஆகாத அப்படியே ஸ்டேஷனரியா இருக்கும். இதுலயும் காயில் தான் இருக்கும், இதுலயும் காயில் தான் இருக்கும். ஸோ இப்போ இங்க வந்து பாத்தீங்க அப்படின்னா ஸ்டேட்டர் அப்படிங்கிறது இட் கேன் யூஸ்ட் ஆஸ் அ காயில். It is a magnetic field. Magnetic field is produced on the rotator. So it is rotating between the coil. What will happen? It's a magnet. So magnetic flux is produced here. That magnetic flux is cut by this rotor, stator. So what will happen? The stator produces the electric field. So here that coils are here. That coil is used as a brushes, and the slip rings are here. This from these slip rings and the coil we can take out the current. Okay. So see that's the stator and outer cover. It's outer cover, and the pulleys are here. It is used to rotate that. It will rotate. Okay. So DC generator is also here. Can produce the DC current and AC current. So it's a magnet. See that. So rotor rotating that magnetic field is produced. So pole rotator. Pole means the number of poles. It's a pole. It's called a pole. So you can see that it's a pole. Pole means that a coil. So one coil is another one coil. That coil is over there. So current is flowing through this coil like this. It will connect in the rotor. Rotor is also a coil. When the current flows through the coil, the magnetic field is produced. Okay. So the magnet is rotating. So it has a magnetic flux. It will rotate. Okay, it's a rotor. It's called rotor. That rotor is placed inside the coil stator. It's a coil. You can take this a coil. When the magnetic flux is cut by the coil, an EMF is induced. That is a property here. That coil is placed over the rotor. What will happen? An EMF is induced. See that blue color 2 light. This is output. So you can get the output current like this. See that output current. In the sinusoidal way, when it is rotated, the current output is producing like this. It's the output current of the generator, alternator. So alternator producing the current like this. So it's a single phase. That is only one current is produced by using that coil. So frequency is F is equal to Pn by 120. 120 is the angle. So N is the number of rotation per minute. Suppose you are placing that another 3 coils. This is called 3-phase AC generator. So it's all connected there. So using that we can produce the 3 times EF. ஒரே ஒரு EMF வந்தது. இப்போ 3 current, 3-phase current. So முன்னாடி வந்தது single phase current. Suppose you are connecting this type of 3 coils, you will get 3-phase current. So see that there are 3 different colors. 3 coils are there. The 3 coils are connected. So current is producing like this. So this is called 3-phase current. So frequency F is equal to Pn by 120. That RPM is 1800. It will produce like this. That angle between that one sine wave, another sine wave is 120 degree. So total 360 degree. Divided by 3, you will get 120. So these 3 output 3-phase current has the 120 degree difference. So coil is producing that EMF like this. See that arrow mark. These are the 3 outputs. The 3 blue color lights. So the 3 outputs. Okay. So here the coil is there. This is a fixed coil. It's called pole. The pole means the space given to the coil which is wounded over that rotor. This is called slip rings. The 2 slip rings are there. that whole core that is connected to the rings. So from that we can take an driven out the current. This is a carbon brushes. So carbon brushes is placed on that slip rings. That is regulator. That's called regulator. From that again that another one DC generator is connected. From that you can produce the direct current also. It's connected to the rectifier. Rectifier, do you know that? By using the rectifier, you can take out the DC current. So AC current and DC current can produce by that alternator. So it's a regular rectangular coil. So this in this method, you are producing the electric current. So alternator, and these are the two flippings, the stator. So when it is rotating inside that, the current is driven out through this regulator. So this also will rotating. From this we can use the pressures or the of rectifier. We can driven out the